Right, now we're going to look at ordering fractions. Ordering fractions. So what that means is we can order something from smallest to biggest or from biggest to smallest. Ascending order, smallest to biggest, ascending the stairs. Descending order, from biggest to smallest. I've got a couple of sets of fractions that we're going to look at ordering. These ones all have the same numerator, but different denominators. These ones all have, these two have, if you can look at them, they have different numerators but the same denominator. These two here, okay, they have different numerators but the same denominator, and then these are all different. So let's look first at ordering these two. A quarter and 2 quarters. Well, which is bigger? Well, it's quite obvious here, isn't it? If I've got something broken into 4 parts, both of them into 4 parts, and I've got 1 of those and 2 of those, then it's really quite simple to understand that 2 quarters here is bigger. So when the denominator is the same, then it's the one with the bigger numerator. So that's easy. So that means with these two here, our biggest fraction is this one, 2/6. And it also means 3 quarters and 4 quarters. If I look at these two, they've got the same denominator, but this one's got 4 in the numerator, so this one here is bigger. So that sort of one is quite easy. Let's look at the next one. 1/3 or 1/5, which is bigger. Now people often see this and think, oh well, this one's bigger. But let's think about it. I've got something which is broken down into 3 parts. And this same thing, this same pizza is broken into 5 parts. Well, if I break it into 3 parts, 1 part is going to be bigger than 1 part if it's broken into 5. So with these, this is big, this is bigger. So here, if I look at these, the smallest is 1/6, because the pizza is broken into 6 bits, have to make it smaller. And then the next one, I've got my same pizza, but this time I only break it into 5 parts. So the piece of cake or the piece of pizza you're getting is a bit bigger. Then now this time with my cake, I only break it into 4 pieces. So the piece that you get is a little bit bigger. Now we're getting really greedy, and we break our cake into 3 pieces, so it's a little bit bigger. Now we break our pizza into just 2 bits, 2 huge bits, a half each, and that's bigger. So when the numerator is the same, the denominator matters, but the smaller the denominator, the bigger the fraction. Now, the final one, and the hard thing with ordering fractions, is when both bits are different. I've got a quarter and 2/6. And here, what I have to do is I have to make the denominator equivalent. And as we talked about when we looked at equivalent fractions, whatever I do to the numerator, I must do to the denominator. So we need to make these two have the same denominator. Now the easiest way to do this is times them by each other to get. What we're looking for is a multiple, a times table that they're both in. Well, they're both, could time them together, but actually I look at them 4, 8, 12, 6, 12. So I need to make this into 12ths. So if I times this by 2 and this by 2, I get 4 12ths. I have to do that with 1/4 too. I need to make it into 12ths because the denominator needs to be the same for us to compare them. So I have to times by 3. And whatever I do to the numerator, I must do to the denominator, times by 3, and that equals 3. So now I can look at them. I've got 3 12ths and 4 12ths. Which is bigger? Obviously 4 12ths is bigger. Now I'm going to use what I just did there to help me order these fractions here. Now I need a number in the denominator, which is, they're in the same times table. They're multiples of each other. Well, 2, let's just jot them down. 2, 4, 6, 8, 10 in my 2's. Let's jot our 4's down. 4, 8, 12, 16, 20. 2, 4, I've done that one. 4, 5, 10, 15, 20. 10, 20. Well, I can see, look, 20 is in all of them, and it will also be in the multiple of 2. I know that straight away. So I have to make the denominator 20. Whatever I do to the bottom, I must do to the top. Whatever I do to the denominator, I must do to the numerator to make them equivalent. So let's make 3/4 first. Well, 3/4. Let's make the new denominator 20. So I have to times by 5. So that means I have 20. I must do that to the top. So that means I have 15 20ths. Let's do this to 4/10. Times by 2. And times by 2 again. And I have 8 20ths. Let's do it with a half. Times by 10. Times by 10 to the top, 2, and I have 10 20ths, and finally with 2/5, times the bottom by 4, times the top by 4, and I have 8 20ths. Right, what have we got there? Well, here I can see then, looking at them, that my smallest 2 fractions are 8 20ths. Okay? So those 2 are equivalent. Then my next biggest, I'm doing these in ascending order, my next biggest is 10 20ths, and then after that 15 20ths. I can obviously still write these in their original format, where we found that 4/10 and 2/5 were equivalent. And then I had that 10 20ths, which is a half, and then finally the 3/4 was the biggest.